Yesterday, when we were adding in scientific notation, like you guys mentioned earlier, we had the same exponent, right? Um, let's start off with that as a warm up. Give you guys a minute. All right, guys. So to do this, just like yesterday, this one wasn't that bad because what do you guys notice about your exponents? They're the same, right? So my answer is going to be something times 10 to the what? Times 10 to the third. Now, where do I get my other portion from? What do I add? And the golden rule to adding decimals is to what? Line them up. So 7 plus 9 is 16. Carry the 1. And then 2 plus 5 is... So my answer is actually going to be 7.6 times 10 to the third. Raise your hand if you got that. Are we okay with this one? Right? Okay. So that was when we have the same exponent. What we're going to be doing today is adding and subtracting scientific notation with different exponents. So the first thing I'm going to write right here is a rule that you guys have to follow. To add or subtract, I should have wrote. So the only way to add or subtract in scientific notation is by having the same exponent. Okay? These are some of the common mistakes that I see. And I'm going to write these down just so you guys see them right off the bat and you don't make them. Okay? If you do make them, it's okay. But these are some common mistakes. We'll call this mistake 1. If I have 5.5 times 10 to the third minus 2.5 times 10 to the first, a lot of people will say, okay, well then I'll just do 10 to the third minus 10 to the first, which is going to give me 10 to the second. So it'll give me times 10 to the second, and then they go 5.5 minus 2.5, which is 3.0 times 10 to the 0. That's a mistake. Okay, you cannot do that, guys. Does anybody know why you can't do that? What's the rule that I gave you guys? The only way to add or subtract is by having the same what? Do we have the same exponent? You don't want to do that, okay? You cannot do that. If you do that, that's an incorrect answer. Okay, circle it, whatever you want to do. Put little stars next to it so that hopefully you guys don't make this mistake. Okay, are we okay with this? Okay, so we do not want to do that. This is the correct way to do it. So I think the question we had was 5.5 times 10 to the third minus 2.5 times 10 to the first. What's the first thing that you guys notice? The first one is times 10 to the what? And the second one is times 10 to the what? So I have times 10 to the third, and then I have times 10 to the first. We have two different exponents, don't we? I want to have the same exponent. Okay, so we have to decide which exponent we wanted to go with. In general, what you want to do is you want to keep the highest exponent. Okay, so you want to keep the highest exponent. What's the highest exponent right now? 10 to the third. So what I want to do is I want to turn this guy into times 10 to the third. So that means all my work, all my pre-work is going to happen was 2.5 times 10 to the first. Okay, I'm not going to do anything to the other one. I'm just going to focus on this guy right here. So it's going to be 2.5 times 10 to the first right now. What do I want to make that? 10 to the what? 10 to the third. So if I want to make that 10 to the third, I need to move my decimal how many times? Not 3 times, 2 times. And your decimal is going to move this way. 1, 2. I need to move it twice. Since I moved it twice, now this is going to become 0 or 0.025 times 10 to the third. Basically, however many times I move the decimal, that's what I add to my exponent. Does that make sense? Okay, so now I can rewrite my equation as 5.5 times 10 to the third plus what? 0.025 times 10 to the what? Times 10 to the third power. Now what do we have? Is that where we want to be? Yes or no? How do we know that's where we want to be? Exponents are the same, right? So my answer is going to be something times 10 to the third. What about, where do I get my other number from? What do I add, guys? 5.5 plus what? Plus 0.025. So when I add this, so my answer is 5.525 times 10 to the third. Do you see how big of a difference that is? Look at the correct way and look at the wrong way. That's a huge difference, isn't it? One of them gave you 3 times 10 to the second. The correct answer is 5.5 times 10 to the third. Does everybody understand that? How that kind of works? Yeah? Okay. And is this in scientific notation? Remember, in order for this to be in scientific notation, my number that I highlighted in blue has to be between which two numbers? 1 and 10. Is 5.525 between 1 and 10?
Yes.
It is, so we're good. Okay, let's try another one. Different exponents, correct? One of them is 10 to the 4th, the other one is 10 to the 5th. Which one do we want to manipulate first, guys? Well, how about this? Let's back it up. What do I want my exponent to be? Do I want to keep the 10 to the 4th, or do I want to keep the 10 to the 5th? 10 to the 5th, right? So I don't have to do anything to this 9.7. I'm good with it. Remember, put it in this little box, put it away, because all the work is going to happen with this guy, right? We want to make this 10 to the what? 10 to the 5th. So the 7.3, we want to make it times 10 to the 5th, right? However, in order to make it times 10 to the 5th, how many times do I need to move my decimal point?
1.
Because I need to add 1 to this 4, right? I just need to move it 1 time to the right or to the left? To the left. Okay? So it's going to become what?
0.73.
Times 10 to the? Times 10 to the 5th. Very good. So let's do that right now. So all my work is going to come from here. So I have 7.3 times 10 to the 4th. But I'm going to move my decimal over once. By moving the decimal over once, it's like I'm adding 1 to my exponent. Okay? So now, this becomes 0.73 times 10 to the 5th power plus 9.7 times 10 to the 5th power. And I'll leave it there, and I'm curious to what your answer is going to be. Go ahead. Check with your partner. I'll give you guys a minute starting right now to solve that and to check with your partner, see if your answer is correct. Remember, it has to be in scientific notation. In correct scientific notation, your answer. Okay. I'm old, everything correct. Got it? Did you check with somebody? All right, let's go. So my answer is probably going to be something times 10 to the what? Times 10 to the 5th. Okay, so I'm going to put that times 10 to the 5th right here. And then my other answer I get from adding 0.73 plus what? 9.70. 3 plus 0 is 3. 7 plus 7 is 14. Carry the 1. This is 10.43. So how many guys got 10.43 times 10 to the 6th? Raise your hand if you got that. Okay? Times 10 to the 5th power. 10.43 times 10 to the 5th power. Raise your hand. Go ahead. Okay? That's wrong. Okay? Liliana, can you tell everybody why this is wrong?
Because it's greater than 10.
Exactly. Okay, I threw that out there just to try to trick you guys. It's not that you did the math wrong. Everything up until this point is correct. But this is not correct scientific notation. In order for it to be correct scientific notation, the number of blue has to be between what?
1 and 10.
1 and 10. So we have to move the decimal how many times?
1.
We need to move it once. So if we move it once, what does it do to this fifth?
Turns it to 6.
Turns it to a 6th power. Does that make sense? Okay. So our real answer is going to be what?
1.043 times 10 to the 6th power.
1.043 times 10 to the 6th power. And now our answer is between 1 and 10. Does that make sense, guys? Yeah? Okay. Are we okay with the addition portion? Let's do some subtraction then. Would we be able to subtract them the way they are? The same rules that apply to addition apply to subtraction. Okay, so which exponent should we keep? 10 to the 6th, right? So we want to manipulate this 10 to the 3rd by moving the decimal how many times? 3 times to the left. We're still trying to make this number go up, so we got to move this to the left. Okay, so what's my number going to be? What's that 9.4 going to become? If you move the decimal 3 times, what's the 9.4 now? Go ahead and do it, guys. I'll give you guys some time. Okay, let's see. Let's call on somebody. Let's go with Esmeralda. Can you help us out? How many times are we moving the decimal? 3 times. So I'm going to go 1, 2, 3. So since I moved the decimal 3 times, what am I adding to this exponent right now? So I'll highlight it. What am I adding to this 3? I'm adding 3 to it. So what's my new number going to be, Esmeralda? A little louder, girl. I can't hear you. That's perfect. 0.0094 times 10 to the 6. Great job. And we are subtracting that from 7.25 times 10 to the 6th. Okay. So let's go with Abigail. What's my exponent most likely going to be? Can I subtract them now? Yes, and it's probably going to be times 10 to the what? So it'll probably be times 10 to the 6th. And where do I get my other portion from? Just like that. Very good. And I'll take over from this one. We can't subtract 0 minus 4. We can't subtract 0 minus 9. We can't even borrow, so we're going to have to borrow from the 5. Then that 10 turns into a 9 because we're borrowing. 10 minus 4 is 6. 9 minus 9 is 0. 4 minus 0 is 4. 2 minus 0 is 2. And then just bring down the 7 because nothing is subtracting it. So our answer is actually going to be 7.2406. How are we doing with that, guys? Any questions on this? Are we good with this? You guys think you can start the homework? Okay.